Okay, this is example 1, page 732, sketch a plane curve. So here's our two parametric equations. X equals t squared minus 4, y equals t divided by 2. What does this here represent? Say again? It's a domain statement, right? It's telling us we want t, which is the independent variable on both of these, to be, greater than or equal to -2, but less than or equal to 3. So it's a domain statement. Okay, so let's make ourselves a table of values. Now, in our table of values, we need to have 3 rows. Right? The first row is t, the next row is x, and the next row is y. And it said to go from -2 to 3. So let me substitute. T is -2, t is -1, t is 0, t is 1, t is 2, and 3. So one at a time, we need to substitute these values of t into the parametric equations. Right? If I put in t is -2 here, what is the value of x? 0. Right? If I put t is -2 here, what is the value of x? -1. Okay. How about if I plug in t is -1? It'd be 1 minus 4, -3. If I put in t is -1 over here, I get -1/2. That is a bad 2, but okay. If I put in a 0, I get x is -4 and y is 0. If I put in 1, I get -3, 1/2. 2, I get 0 and 1. And 3, I get 9 minus 4 is 5. And 3 over 2, 3/2. So I'm just plugging in for x and y. Okay, now let's graph that. And I can tell that my x values go from -4 to 5, and my y values go from -1 to +3/2. So there's -4, there's 5, there's +1, +2, -1. So let's graph all of these x, y points, right? We're not graphing the t, right? We use t to get the x and the y. Now we graph the x and the y. 0, -1. -3, 1/2, -1/2. -4, 0. -3, +1/2. 0, 1. And 5, 3/2. So connect all of those with a continuous, smooth line, and that's the plane curve, except it's missing one thing. What's it missing? It needs an arrow, right? As we let t increase, the curve was traced like this. So that's the graph of a plane curve.